Welcome to Tech Teach.
So first of all, we will be going with the content like the basics of the computer system. So in the computer system, here we are going to introduce like what is a computer system, how it is made up of, and what different components are there, what is the different functional blocks are there. We will be explaining these blocks one by one. So basic computer system you can think of as a black box. So in the black box, you can call it like there is a black box. In this black box, we are having few inputs. We are having few inputs and we are having few outputs. So we are having few inputs and we are having few outputs. So with respect to these inputs, there is a system. This is a black box that can be a system. So it is a system that is going to process this input and it is going to deliver an output. So inside this system, that is the black box, what is different components? What are the different components? How they are connected? This is all about the computer architecture and organization. So architecture, so if it is going to have a processing system, so there will be this black box will be, if we say it, so how this black box look like. So inside this black box, there will be a processing system. So there will be a processor. This processor will be working on the data that we are providing input from outside or from a memory. So we are providing the data from a memory. So there will be a memory requirement. And also we can have the inputs and we can have the outputs. So to connect input and output, we are having input output. Unit. This is like memory unit. This is input output unit. And these are connected with each other. So to connect, we are having system bus. So the connections are basically done by called system bus. Bus is like a path to basically transfer data or to transfer an address or to transfer some control signal. So that system bus constitute these three. That is data bus, address bus, and control bus. So architecture in the sense how these components are organized. Okay. How these components are organized and how they are connected with each other. So by definitions, we will be just going through. So computer organization refers to the operational units and their interconnections that realize the architectural specifications. These are the architectural specifications of this black box, and they should be connected in what manner by different interconnecting devices or interconnection devices basically, or the buses basically here. So that way of connecting these components or the blocks into an orderly way so that we have output to define based on some input. So we will be connecting these components in an organized manner that is going to have the organized computer organized. The connections will be done by using the interconnects. Further, we can explain is like these components are made up of basically the electronic devices. Okay, we are having electronic devices and we are having certain desired behavior. If electronic device, so all the components are made up of the electronic devices. And if we are having the electronic devices and we want some output, like we want to implement an adder, suppose we want to add an two inputs we want to add and we want to implement an adder circuit. So into this adder circuit, if you want to add, so there should be some system here. So we are having the electronic devices that will be used to implement the adders, and output we know how the desired behavior, its behavior should be the addition of the data. Okay, so for that we will be using these electronic devices, but we should be organizing it into a certain manner so that we can get the desired out. So that is the organization part. So we can just see here. So that organization part that we are doing is going to have a general purpose computing. So general purpose computing in the sense we are having few desired behavior that we want to replicate by using a system. That system will be a general purpose computer. So we are having electronic devices. We want some desired behavior, but that desired behavior is being implemented by using this general purpose computing system. So this general purpose computing system is done in such a way we are able to get the desired behavior. So we are having the basic devices, that is electronic devices. We will be organizing it such that we will be getting a general purpose computer system. And by using the softwares, we can get the desired behavior. So this is how the role of computer organization comes into picture. So we are having the basic components, but we should be organizing it such a way that we should be getting our desired function or behavior, like an addition. So we will be having electronic devices. We will be organizing it such a way that we are getting the addition as an output behavior. That is done by using the computer organizer. We are organizing the components to get a certain behavior. In computer system, basically the computing is done by using the processors. So these are the structure of a processor, how the processor structure or the IC basically look like. Inside it, if you will be looking it out, there are many components. That components are basically includes the basic electronic devices like the transistors. You may have know like what is transistor. Transistors are like BJTs and MOSFETs most frequently that we basically use. So these transistors are going to constitute the micro processors or processors basically. So processors are considered to be the heart of the computer system because it is the one that will be doing all the processing. We can go somewhat deeper into the architecture of the computer system and how the different components are organized together. So into a computer system, we are having a CPU. We are having a CPU that is a processor. So we are having a CPU. We are having input output module. We are having the memory, main memory or memory unit. So memory unit, input output unit, and the CPU are the processor. And these three components are combined together by using the system bus. There is a system bus that will be connecting all these three components. So that is the basic overview of a computer system. If we go deeper into the CPU, so CPU, how it look like? So CPU, inside the CPU, there will be ALU, that is called arithmetic and logic unit. We are having registers. So you may have gone through the term flip-flops. So these flip-flops are the basic electronic device. Like D flip-flop is there. So D flip-flop, there will be a clock, and it will be having two outputs, Q and Q bar. This is the D flip-flop. So if one flip-flop is there, so one flip-flop will be storing one bit of information. If we are going to connect the different flip-flops, so suppose one flip-flop is another flip-flop. So suppose four flip-flops are connected together, then it will be forming a register. So it will be called, now it will be called a register. And this is a register that is having four flip-flops. So it will be a 4-bit register basically. 4-bit register. So these registers are there inside the CPU. So these registers are considered to be one of the fastest memory element. So these are the fastest memory element. In between different memories that we have to a computer system, the registers are considered to be the fastest one. And along with that, we are having control unit. Like arithmetic and logic unit that is basically useful for performing the arithmetic and logical operations. Control unit for performing different control related operations. It will be providing control signals throughout the computer system. All these components are connected with internal buses. So ALU, control unit, and registers will be connected with their internal buses. Further, the control unit is been explained here. So inside the control unit, what are the different components? So there is sequencing logic, there is control unit registers and decoders, and there is a control memory. So these are the different components, sequencing logic. So that will be used to sequence different operations. Control unit registers. So how to control the registers value? When to we have like reading the data and writing the data into the registers. How to decode the values. So this is the top level structure of a computer system. So starting with the main basic components, input, output, memory unit, and the CPU or the processor. And inside the processor, we are having these components. And further inside the ALU, sorry, inside the control unit, we will be having these components: sequencing logic, control unit, registers and decoders, and memory control unit. So of a computer system, we can think of like a processor and then the memory and the input output. So input output unit that will be basically helpful in connecting the input and output devices. Memory, that is the main memory basically. So how the main memory will be there like RAMs. So RAMs are the main memory and the processor. So in basic structure, we can draw the functional units likewise. But if you go deeper, we can think of likewise. Okay. So we are having the different components. They're connected with the system bus. Here system bus is not shown. Okay. And we have further divided like CPU. What is inside the CPU? We can draw it here. We are only written arithmetic logic unit, register control unit, and also we should be writing like registers are there into this processor. So in terms of the functional units, you can explain these components as the functional unit. So what is the role of memory, input devices, or input unit, arithmetic logic and control unit? We will be just going to see further. In terms of memory, we talk about. So here it stores program and data. So memory will be the one memory unit that will be the one that will be storing the program as well as the data. Here two classes of the storage is there. One is the primary storage. Another one is called the secondary storage. So primary storage are considered to be the fast one. Secondary storage is considered to be the slower one. Programs must be stored in memory while they are being executed. This primary memory is considered to be like the RAM we can talk. So in the memory unit, it is going to constitute different memory components. So we are having the RAM, we are having the hard drive also into the computer system. So hard drive that comes under the secondary memory. That is the secondary storage memory. Primary storage memory means the RAM. It will be storing the programs and the data that is going to be executed into the processor. Large number of semiconductor storage cell. So here many number of storage cells are there, semiconductor cells that basically constitute the RAM. Processed in words. So whatever is the information stored here, it will be processed by the processor in terms of words. So what is a word? So processors are basically considered to be like a processor is of 8-bit, or we can say like a processor is of 16-bit. So if an 8-bit processor is there, its meaning is the processor can process 8-bit at one time. At one time, it will be processing only 8-bit, not larger than 8-bit. Its meaning here the word size will be 8-bit. Similarly, if a processor is there that is of 16-bit, its meaning it can process 16-bit at a one time, and then the word size will be here. Word size will be 16-bit if a 16-bit processor is there. Similarly, we are having 32-bit or 64-bit processor is there. Its meaning the processor can process 64-bit at one time, and the word size will be 64-bit. So here, with respect to the processors, the data is basically processed in terms of words. Addresses. So address in the sense there are different methods. Two different methods are there to explain like how the addresses are basically defined in terms of memories that we will be looking later on. So RAM and the memory access time. So if the RAM is there, if you think of, so RAM and the secondary memory or different memories categories are there. So if we think of the memory hierarchy, so there is a cache memory, there is a main memory, and then the secondary memory. You can think of like if the processor is there, or we call it like microprocessor. If a microprocessor is there, so microprocessor is having registers. So this with the microprocessor, we are having registers. After that, we are having the cache memory. So this cache memory is also inside the registers, inside the processor. After that, we are having RAM. After that, we are having the hard drive, HDD or SSD. If microprocessor wants to do some processing on the data, it will be asking or it will be looking into the registers first. If it is available here, it can use it from the registers directly and do the processing. If it is not here, it will be looking into the cache. If it is available into the cache memory, it will be, if needed, it will be transferring it to the registers. Otherwise, it will be taking directly the data and doing the process. If suppose the data is not here, then it will be going to the RAM. Similarly, if data is not there into the RAM, it will be going to HDD. It will be transferring the data from here to RAM, then from RAM to cache memory, then to registers, and then do the processing. So if the processor is going to do any processing, it is suitable to put the data into the registers. So if the data is put into the registers, it is going to take less time to access the data. If the data is available into the RAM, it will be taking more time to access the data from the RAM. If the data is available into the cache memory, it will be taking less time to access the data. So similarly, there is a hierarchy of the memories. So this is called memory hierarchy. So into a computer system, we are having the memory hierarchy. So up to here, so registers and cache memory are within the CPU. It is within the CPU. RAM is considered to be, it is outside the CPU. RAM is outside, so it is called the primary memory. And the hard drives are considered to be the secondary memory. So secondary memory is the, you can think of like, basically the secondary memory is used to store the backup sort of data. It's like secondary. So it is not the primary requirement. Secondary data is like that is not required. We will be storing it as a backup or into a secondary memory. So if we are considering in terms of the speed, what is the speed, what is the cost? Okay, what is the speed and what is the cost? So speed is highest here into the registers. So speed, if you can think of, speed is higher here. Cost. So cost is also like higher here. So cost is higher. So if you are going to purchase a cache memory and if we are comparing the cost of cache memory and RAM, the cost of cache memory will be higher than the RAM. RAM, if it is compared with the hard drive, RAM cost will be higher with respect to the hard drive. And the capacity, one term is capacity. So capacity is always higher into the hard drives. So if we think of, so hard drive is having the higher capacity, but speed is low and the cost is low. If you think of RAM, RAM is having lower capacity than the hard drive, but it is having higher speed and higher cost. Cache memory is having the very high cost and very high speed compared to RAM and hard drive, but its capacity is less. Registers, so registers are having the highest cost, you can call it, consider it, okay, and its speed is highest, very fast, and its capacity is very less. So you can think for an example in computer system, hard drives So hard drives are basically, this SSD is in TB. We are having 1 TB hard drive or SDD or SSD. In RAM, RAMs are in GB. Cache memory is in MB basically. And the registers are is in bits. It is in bits. Registers are generally of like 64-bit, 32-bit register. So registers are in bits. Cache memory is in MBs. RAMs are in GBs. And hard drives are in TB. So capacity wise, you can just look at it. Higher capacity is this one, then lower, and further lower. So capacity is lowest in terms of registers, but speed and cost is very high in terms of register. So these are the different memory system of the computer system basically. So secondary memory is like the one that is used as a backup storage. This is the secondary. Next component is the arithmetic and logic unit. So the basic role of arithmetic and logic unit is, as the name suggests, it will be performing the arithmetic as well as the logical operations. So most computer operations are executed in ALU of the processor. So because it is doing the arithmetic and logic operations, so most of the processings of the computer system is basically done by the ALU only. So ALU is responsible for performing the operations into the computer system. Load the operand into the memory, bring them to the processor, perform the operation in ALU, store the result back to memory or retain in the processor. These are the steps followed for instruction execution. If you are executing any instruction, you need to perform these steps. So first of all, load the operand into the memory. Suppose you are doing add operation. Suppose we are adding R1 with data. That is whatever is the data, that is data is like 5 or whatever data is there. So you want to add a data from with R1 and store the result into R1 like this. So here first one is like load the operand into the memory. So load the operand, that is data, into the memory. The data should be there into the memory. Bring them to the processor. So data needs to be bring from the memory to the processor. Perform the operation in ALU. So once the data R1 is already available into the processor, data is fetched from the memory. So data as well as the R1 content is available to the processor. Then ALU will be performing the operation adding. Then after adding, the result will be stored back into the memory. The result can be back stored into the memory, or it can be retained into the registers of the processor. So retain in the processor, in the sense it will be retained in form of registers of the processor. So registers. So registers are, there are different types of registers are available into the memory, the processor. So that we will be looking it out. So these registers are basically used as a temporary registers to store the data for a temporary period. So once the addition is going to be done, so R1 will be a register, temporary register. So it will be storing the R1, the data into the R1 for a temporary period. If some other application operation is being performed, the R1 will be storing some other data. So based on the instruction, the R1 or the registers will be storing the values for temporary period. First control of ALU, so arithmetic and logical unit, is basically going to have the first control on ALU if we are using the registers. So register, so it is preferred to use register operations for performing ALU operations so that we can have faster ALU operations. If we are going to fetch the data from memories, it will be taking more time. So instead of using memory data, we should be using registers to store the data, and then the operations should be done on registers only. It will reduce the time of execution of an instruction. The role of arithmetic and logic unit is basically to perform arithmetic and logical operations at the processor. Why there is no 128-bit processors? So in computer system, we see whatever most of the computers we are having, it is either 32-bit processor having or it is having 64-bit processor. There is no processor that is of 128-bit. So everyone just search it out, like why there is no 128-bit processor available. Next one is the control unit. So we'll see what is a control unit. So control unit, all computer operations are controlled by the control unit. All computer operations will be controlled by the control unit. So control unit is responsible for controlling the operations of the computer system. Its meaning is like if addition needs to be performed. So in the previous example we have seen addition is going to be performed. So it is said like load the operand into memory. So how to load the operand into the memory? Its meaning is first of all we will be loading the data into the memory from suppose from input device. So input device we are having keyboard. We want to put some data into the memory. So we will be inputting the data from the memory from the keyboard to the memory. If we are going to press the keyboard button, it's meaning the data from the keyboard should be copied to the memory. That should be done with respect to the control. Control unit should be activated such that there should be a memory write operation should be activated. So control unit will be activating a memory write signal, and then it will be taking the data from the keyboard and putting it into the memory. Then bring them to the processor. So if we want to bring the data from memory to the processor, then these components, memory and all, are connected with the data bus, address bus, and control bus. So bus control unit will be generating a signal to read the data from the memory by the processor. Because bring them to the processor, its meaning is processor will be reading the data from the memory. So for that, control unit will be activating signals like memory read operations should be activated. And once the memory read signal is activated, and along with that, it will be putting the address to the address into the memory from which memory address the data should be read. That address will be put on the address bus. So at that particular time, whatever is the address at that address, whatever is the data that will be copied from this memory and put on to the data bus. And then that data bus will be fetching the data from the memory, placing it on data bus and bringing it to the processor. So processor will be able to access the data from the data bus. So all this thing, when to activate the address bus, when to activate the control signal, when to activate the data bus, that is basically controlled by the control unit. So all computer operations are basically controlled by the control unit. The timing signals that govern the input-output transfer are also generated by the control unit. So timing signals. So all these things that needs to be done at when to activate the writing data into the memory. After certain time, the data needs to be copied from the memory and bring into the data bus. So all these are done with respect to time. So that is basically called timing control. So control unit basically does the timing control also. So what function needs to be performed, but at what particular time needs to be performed, that is also controlled by the controller. So there is a timing signal that basically also govern the input output transfer. So as we are putting some data from external device like keyboard to the memory, so loading the operand into the memory, so that is done by the keyboard. So if we are putting some data from the keyboard to the memory, then also that is considered to be input output data transfer. So that is input output data transfer. We are transferring the data from input device. So that will also be controlled by the control unit. Control unit is usually distributed throughout the machine instead of standing alone. So the control unit will be connected with all different components of the computer system. It is not a separate device that is just connected or just constrained to its own only. So control unit is having monitoring to all the different components that are connected to the computer system. Operations of a computer is just summarized in few points. Is like accept information in the form of program and data through an input unit and store it in the memory. Fetch the information stored in the memory under program control into an ALU where the information is processed. So it's like the same thing is being explained further here. So it will be accepting the information in the form of program and data through an input unit. So whatever the programs and data are there, that will be uh, put at by the input devices and it will be stored into the memory. So that memory, the basic memory, like whatever the programs and all will be there, that will be stored into the hard drives. Okay. So once it is stored in the hard drive, and if that program, suppose there are 10 programs stored into the hard drive, if suppose programs are like, suppose word processing, we are having, we want to prepare a PPT, so PPT software will be stored there. Some suppose WhatsApp is there, you want to access WhatsApp on the desktop or computer system, WhatsApp software installed. So all will be stored on the hard drive. Suppose you want to access WhatsApp. So once you will be opening the WhatsApp, its data will be copied from the hard drive to the RAM. It will be coming into the RAM. Now you want to access the WhatsApp. Along with that, you want to prepare the PPT. So once you will be opening the PowerPoint application, the PowerPoint application that is stored on the hard drive, it's some part of the data will be copied to the RAM. So that is accessing the data, basically storing it into the RAM, that is the primary memory. So it is like, first of all, we will be storing the programs into the hard drive by the input output device. Okay. And we will be putting it there into the memory, then fetching the information stored in the memory. Whatever the data available into the memory, like hard drive, it will be fetched by the processor. So it will be fetched by the processor, first put into the RAM. From RAM, it will be put to the cache, then it will be going to the processor under program control. So it will be done by using the program control. Into an ALU, it will be coming, the data will be coming to the ALU and performing some operations. It will be doing some processing. Then output the processed information through an output unit. So after processing the data, it will be providing the output at the output unit. So output unit is like the monitor or a speaker. So these are like the output unit. So if there is a music, it will be taken out as a speaker music sound. If it is a content that should be displayed on the monitor, it will be displaying the monitor by the output unit. Control all activities inside the machine through a control unit. All these activities will be controlled by the control unit basically. So the different operations that are being performed will be controlled by the control unit. So that is the role of control unit. So basic connection between the different components that internally look like is given by this structure that is basically called data path and control. Data path and control. So here we are having memory that is storing the instructions. Instructions are like we want to give command to the processors. So we give in the form of instructions. So the processors are having the instructions. We will see later on like what are the instructions are there. So instructions are there that is stored into the memory. It's like this memory, like the primary memory, like RAM is there. It is stored into the RAM. Once a particular program is being accessed, the program will be copied from the hard drive to the RAM. So from RAM, the processor will be accessing the data. So into this RAM, where is the program or where is the instruction uh, stored, at what address location the instruction is there, that is given by the PC. That is called the program counter. So program counter is a register that stores the address of next needs to be processed or executed by the processor. That is basically done by the processor basically here. Next, the data will be copied from the memory, that is RAM, to the registers if required. If some ALU operations are there, it is try to copy the data into the registers, and then based on the registers, the ALU operations will be done. For performing an addition, two inputs are required or two operands are required. That will be in terms of other data that can directly be put or register data. And then there will be ALU operation. After ALU operation, the result will be stored into a memory or it will be given back to the register. It will be stored into the back into the register. The same above operation, the same operation that is explained here, the same is being done like how it will be done inside the processor, how it will be performed by the computer system. So I hope you have got the basic idea about uh, the different components of the computer system. Computer system that is having multiple processors. In that, how the system will look like. So there is a motherboard. Onto that motherboard, there will be a processor chip. There will be main memory chips, and there will be input output chips, and some other components will be there. So, but definitely there will be three different main functional components are there: processor, memories, and input output chip. Input output basically. So if this is the system, then the processor, if it is a multi-core processor or multiple cores are there, means multiple processors are there. If the multiple processors are there, so it will be like processors. Inside this, if it is multiple processor, inside that there will be different cores. Cores in the sense there are multiple processors. And inside that only we will be having the cache memory. So processors will be having the cache memory, that is L3. So what is L3? We will let's looking it out. So these are the processor chip. Inside that there will be different cores, different processors. So it is 8 cores are there. So it is octa-core processor. Each core, what is inside this each core? So each core will be having the instruction logic, arithmetic logic unit, load and store logic. So it is like ALU, part of ALU. Okay, and there will be the memories. So memories will be like L1 I cache, that is instruction cache, L1 data cache, that is cache memory there. So you can look at here L2 instruction cache and L2 data cache. Its meaning is like, so inside this course, there is a cache memory defined. So there are different stages or different hierarchy of the cache memory also. So to further increase the performance of the computer system, we are using different levels of the cache memory. So inside the core, there will be L1 and L2 type of cache memories for instruction and the data. And then if it is commandly on a processor chip, so it is having L3 type of cache memory. So L3 cache for instruction and for data. So this is structure, like how a simplified view of the major elements of the multi-core computer system can look like, that is given by here.